Greeting my excellent friends. Welcome to the Common SQL series, where we learn the most common commands and queries that are being used in the industry. Today, we will learn about SQL window functions. I would say SQL window function is actually not so common, but more like an advanced feature. But it's very powerful and useful when you need to do some complex calculations, especially if you're doing some data analysis or data engineering work. And this video will give you a good introduction to SQL window functions. Anyway, let's get started. SQL window functions are a powerful feature of SQL that allow you to perform calculations across a set of table rows that are related to the current row. But before we dive into the details, let's first understand a simpler concept: aggregate functions. By definition, aggregate function means multiple values are processed together to form a single summary statistic. There are common aggregate functions: sum, count, average, min, max. Actually, I think you might already be familiar with those functions. If not, please leave me comment below, so I will create more videos on that topic. Let's quickly go through some examples. Let's say we have a table like this. This table tracks the number of sales for each salesperson on each country. Let's use some aggregate functions. Just like definition, the aggregate function sum, average, min, max will process the entire dataset and result a single row with the aggregated summary. And instead of aggregate the entire dataset, we can also split into groups and process each group. Here we divide the dataset based on person and perform the aggregate functions on each group. Using aggregate function is straightforward. Let's move on to window function, also called analytic function. By definition, window function uses values from multiple rows to form a single value for each row, without collapsing the rows into one. This contrasts with aggregate function, which forms a single value for multiple rows. The key word here is over. It's specifically used with window function. Whenever you see a function used with over clause, you will know it's window function. Some aggregate function combined with over will result window functions. But there are more functions. Here is the list. Let's explore some popular window function usage. First, let's try the sum function. We use the sum function together with the over clause to make a window function. Here, we accumulate the sales from all person, start from ID 1 to the end. You can see the sum calculation is performed on each ID, one by one, respecting ID order, ascending we provided. On each ID, the results show the accumulated sum of current ID and previous row's result up to that point. Each ID is corresponding to a step of calculation. Let's take a look at each step by step. We start at first step. The current row is at ID 1. The window contains only the row with ID 1. The sum function results just 100. Just 100. Next step. The window is expanded to one more row. Now it contains ID 1 and ID 2. The sum function calculates the total sales value in the window, and the result for current step at ID 2 is 210. Next step, the window is expanded to one more row. Now it contains rows from ID 1 to ID 3. The sum function calculates the total sales value in the window, and the result for the current step at ID 3 is 330. For this example, in the case of the clause over order by ID, the window is sliding, includes all rows from the start of the result set up to the current row based on the ID'd order. As you move through each row, the window expands to include more rows, allowing the window function to compute its result for each row within that growing set. The window is not limited to sliding method, but it can also be the entire dataset or separated partitions. We will look into them later, stay tuned. And so on, down to the end of our dataset. You can see with the window function, we actually applying the sum function to calculate the value for each row, according to other rows in the current window. It operates over a specific window or subset of rows in the result set, defined by the over. without collapsing the rows like aggregate functions do. Let's try a slightly different example. Instead of perform calculation on each ID, we perform on each unique person. Here, the window is similarly defined as the set of rows from the beginning up to the current row, but in this case it's ordered alphabetically by the person column. The important difference here is we divide step by each person, so all rows with the same person will belong to a step. So when window sliding, it will expand all the way to the next person instead of one row, one by one. All rows with the same person value will share the same result for the window function. Let's try another function, max. We're still making sliding window one by one by ID'd ordering. At each step, we determine that maximum value from the start of window to the current row. Okay, well done. We learned some basic about the window function. Now remember, I mentioned about the styles of window. Not just sliding window, we also have the partition window, where the function applies to a smaller portion, called partition. Let's try window function on the partition instead of the sliding window. I still keep the sliding window function accumulated for comparison, so you can see the main difference here. With the partition by clause, the window doesn't slide, but cut off when jumped to next person, just like each person will have independent window, compared to the order by sliding window, which accumulate value from beginning. Here the value is reset when person is changed, because it creates separate window for each person. The partition by clause is particularly useful when combined with some window functions, like ranking function, which we will cover in the next section. But before we move on, there is one more case that we need to cover. That is the case when the over clause is empty, like this. In this case, the window function is applied to the entire result set. The calculation is performed over entire result set, all at once, no window sliding, not partitioning. This is rarely useful, but still, we know how it works. Okay, it's time to move on to the next interesting topic, ranking functions. Ranking means assigning a number to each row based on some criteria. For example, in a class, based on the score, we can rank students. Who is the best student? Who is the second best student? And so on. In SQL, there are several ranking functions such as row number, rank, dense rank, and antile. We will discuss each of them in detail. Let's take a look at simple table, students with their scores. Now we will rank student based on their score. First, we will use the rank function combined with over, order by score, descending. In other words, we sort students based on their score, highest score first, and then assign the rank to each student. That's how the rank function works. You can see the ranking from highest score to lowest. You might also notice that there is tie on second place and fourth place. That is the nature of the rank function. Let's try other ranking functions. To easier visualize and comparison, we will use all ranking functions at once. Rank, denser rank, percent rank, row number, entile. And the result is like this. Let's explore the result from each function and compare to others. We already learnt about the rank function, and notice there are gaps in the ranking. Like in the example, there is gap between 2 and 4. Also, there is gap between 4 and 7. But what if we want to fill these gaps? We can use dense rank function. It is similar to rank function. All students with same score will get same rank. But it does not leave any gaps in the ranking. It treats the ranks as continuous numbers. Moving on to the next, it's percent rank function. Percent rank is a window function that returns the percentage distribution of a value. For example, Daisy and Frank, two students with score of 80, belongs to the top 14% of the class. Moving on to the next, it's row number function. Row number is a window function that assigns a unique row number to each row within the window. The row number starts with 1 for the first row in each window. If instead of order by you use partition by, the row number will reset for each partition. This is pretty useful when you want to assign a unique number to each row in a result set. Now, the last ranking function we will discuss is endtile. Here, we call the endtile function with argument 3. That means we want to divide all students into 3 groups or buckets, and based on the score, students will be assigned to one of these 3 groups. Here, for example, we don't want to classify students based on absolute scores, but instead we want to classify students into 3 groups: top, middle, and bottom. Well done! Now we know how to use the ranking functions. Let's move on to the last window function category, value functions. Value functions are used to access the value of a specific row. For example, we can access the value of the previous row, the next row, or the first row in the group, etc. Possible value functions are lag, lead, first value, last value, int value. Let's use a simple table, tracking temperatures, date by date, also with a city column, and then apply the lag function to the temperature column, ordering by date. And we got the result like this. Let's interpret the result. First, it sorts the dataset by date, then it applies the lag function to the temperature column. That means getting the temperature of the previous date. You can see the first row has value of null because there is no previous row to take. Here, the city column is not used and is irrelevant. What if we include the city column with partition by clause, like this? We're partitioning by city and also sort by date. You can see in the result the lag function still takes temperature from the previous row. But since we use partition by city, it only takes the previous row from the same city and resets when the city changes, similar to any other window function that we learned before. Moving on to the lead function. Lead function is similar to lag function, but it takes the value from the next row. Moving on to the first value function. As the name implies, the first value function returns the first value in current window. And then the last value function. This function returns the last value in the window. But there is a catch. Look at the result, you might be confused. Remember, in previous couple sections, we got the window where there are duplicate values in the order by clause. Here in this example, the date column has duplicate values. And so, calculations with the same date value will return the same result. In other words, for each row, take the temperature from the last row, that is, on the same date. This behavior is due to the nature of sliding window, which is the default behavior for window functions. But you can change it by specifying the window frame, which we will cover shortly. Now, let's see the last syntax of the SQL window function, the window frame clause. Frame clause is included inside the definition of window, like following the order by or partition by. It is used to specify the window frame for the window function. The default frame clauses range between unbounded preceding and current row. This means that the window frame starts from the first row and ends at the current row. This behavior is what we've seen in all previous examples from the beginning of this video, where we omitted the frame clause. When we specify the frame clause explicitly, we override the default behavior. Here is the syntax and the options that we can use to define the frame clause. We will not go into the details of these options in this video, but let me show you an example of using the custom, non-default frame clause. We will use the example at the beginning of this video. Here, we use max function on the sales number of each person. When omitting the frame clause, the query will use the default frame clause. Here is the result. Now let's specify the frame clause, but using the definition exactly the same as the default. Obviously, the result will be the same. Now, let's change the upper bound to unbounded following, and execute the query again. You can see that the result is different. The max function now returns the maximum value ranged from the first row to the last row. Now, Instead of limit itself to the current row, at each step, it can look ahead to the last row. That's why it can see a single maximum value over the entire dataset, which is 330. Let's do another change. Now we change the lower bound to current row. We want the query to look into a range that starts just from the current row until the very end. That means, at each step, the window will not include the previous rows. Execute the query, and you can see that the result is different again. This time, at each step, the window is limited to the current row, expand to the end. So, at ID 10, the window is no longer include the sales number of 330, but instead, it only includes the sales number of 60, 80, and 90. The max function will result 90, which is the maximum value of the window. Okay, that's quite long video. We already covered a lot. I think we can do a quick recap of what we have done so far. First, we went through the basic definition of the SQL window functions. We know that they can be identified by the over clause. Then, we learned why it's called a window function. It's because it operates on a window of rows. The window can be sliding, partition, or entire dataset. Next, we learned about the different types of window functions. We have the aggregate functions, ranking functions, and value functions. Finally, we learned about the behavior of window frame and how to change the default behavior. That's all I have for you today. If you have any questions or comments, please put it below. And don't forget to subscribe to see more video like this. Thank you and have a nice day.